Your objective for lesson 8 is I will represent measurement data with line plots. So we're still working with the line plots, and you're going to be making your own line plot again, looking at measurement data just like we did in the last lesson. So you're going to have this piece of paper in your binder where it says heights of sunflower plants. So make sure that you have this ready and in front of you to work through the first part of the concept development. And this on the screen says Mrs. Schott measures the heights of the sunflower plants in her garden. The measurements are shown in the chart below. So when we're looking at the chart, you have to ask yourself what data is shown in the chart, and we know that the data that's shown in the chart are the different heights of the sunflower plants that are in her garden. How does the data in this chart compare to the data we plotted yesterday? And if you think back to what we did yesterday, and then when you're taking a look at this chart right here, you should recognize that there's a lot more heights, a lot more numbers in this chart, so we're going to be plotting a lot more on our line plot for today. Okay, so now we're going to start making a line plot to display all of the different heights of the different sunflowers in her garden. So we've got to think back to what steps you're going to take to be able to create the line plot. One of the first things that we'll have to do is get a line drawn and figure out what that first tick mark is going to be, what number is going to go for that first tick mark. And if you remember, the way that we find the first tick mark or the number that goes first is by finding the smallest number in the chart. So I want you to go and I want you to look in the chart and I want you to find the smallest measurement on the chart and I want you to circle that so we know where to start on our line plot. Okay, so you should have circled 60. That would be the smallest height of her sunflowers in her garden. So our first tick mark on our line plot is going to be 60. Now we need to look and find the last tick mark because we know that we're going to be looking for the largest number in the chart and we know that's going to be our last tick mark. So I want you to put a square around the largest measurement on this chart so we know what our last tick mark is going to be. Okay, so the number that you should put a square around is 64. That is the largest measurement that you see on the chart. So we're going to start our line plot at 60 and we're going to end our line plot at 64. Now we just got to figure out what intervals we're going to use, what else we're going to put in between 60 and 64. So you really have to take a look at the fractions that are with all of these other numbers. And when you're looking at them, I see a half, all halves right here. These are halves, and these are halves. So we've usually worked a lot with fourths, and now we don't see any fourths, we only see halves. So we know this one's probably going to be a little bit easier because if I'm at 60, to get to 61, I would have to go 60, 60 and a half, and then 61, and then you would go 61 and a half, and 62, 62 and a half, 63. So the halves are really easy whenever we're using those to make a line plot. So now we have figured out our first number on the line plot, which is 60 inches. And then our second one is 64, and then we've got to put in all the other ones in between. Okay, so now that we know that we're going to start at 60 and you know all of the ones that go in between it by looking at this chart, I want you to go ahead and create your line plot. Make sure that whenever you're plotting your X's, that you're checking them off on this chart as you do it, so that way you don't put it more than once. And when you create it, you're also going to have to put the labels and the title. So you're creating this all on your own right now, since we've worked on it for the past few lessons. So once you've created your line plot and put everything on it that needs to be on it, I want you to push play. Okay, so this is what your line plot should look like. The title of it is Heights of Sunflower Plants, and the way that you got the title was just by looking at the chart. You should have labeled that the numbers were representing inches and that each X stood for one plant. If you put that it was one sunflower plant, that's fine as well because that's the type of plant that we're looking at. Now on your piece of paper where you made this line plot underneath the chart, I want you to write a statement that is true about the heights of the sunflower plants in her garden based on this line plot. So I'm just going to give you one as an example. This isn't the one that I want you to write down. I want you to come up with one on your own. But a statement that could be true is that in her garden, she had 2 sunflower plants that were 64 inches tall. And the way I figured that out is I look over here at 64 inches on the line plot, and I see that there's 2 X's above that, and I know that each X represents 1 sunflower plant, so the 2 X's must mean that those are 2 sunflower plants that were 64 inches tall. So I want you to write a statement on your piece of paper that is true about her sunflower plants based on what you see here on the line plot. When you have that written down, I want you to push play. Okay, so now we're going to work on some questions based on this line plot. So you're going to use the same piece of paper. You can use the back side of it or the front side of it. Just don't make it all scattered and messed up everywhere, because whenever I look at this paper, I'm going to want to see the actual different answers that you have. So kind of be neat and organized of where you're putting your answers on the paper so it's not messed and sloppy looking, and I can actually understand where the answers are. So first question that we're going to answer is, what are the 3 most frequent measurements in order from shortest to tallest? So you're going to have to find the 3 most frequent ones, meaning the ones that have the most X's, and you're going to have to arrange them whenever you're putting them down on your paper from the shortest to the tallest. So I know right now that this 62.5 is going to be the one that happened most frequently because it has more X's than any other one. I know that the one that's going to come next is this one because I can just tell by looking at it that it has more X's than the others. And I know that 63 has more X's than the others. I know that there's 61, 61.5, and 63.5 that have 3 X's, but we're not going to deal with those because it says what are the 3 most frequent measurements. So we're looking for the 3 measurements that have more X's than the others. So now that we've pointed out which measurements have the most X's, now you have to write those measurements on your paper from shortest to tallest. And we know that down here at 60, this is the shortest measurement, and when we go up here to 64, that's the tallest measurement. So you're just writing it down like it would be on the line plot. You're going from left to right because that's going from shortest to tallest. So once you get those 3 measurements written down on your piece of paper for this first question, and push play when you're ready to check it. So you should have wrote 62, 62.5, and then 63. If you put 62.5, that's not right because you were thinking that 62.5 had the most X's, and that's right, but it said to list them from shortest to tallest, not from the most X's to the least amount of X's. 62 was the shortest out of those 3 measurements, and 63 was the tallest out of those 3 measurements. How many plants were measured in all is our next question. So I want you to look at the line plot and look at all those X's to see how many plants were measured in all. And I want you to write that number on your paper and push play when you're ready to check it. So there were 30 plants that were measured in all. You could have looked at the chart possibly and counted how many were in each row and kind of did a multiplication equation to figure it out, or you just can count all of the X's and that would have given you 30 as well. So the next question, what is the total number of plants that measure 62, 62.5, and 63 inches? So we're looking at the ones that have the most X's, which are the ones that we just looked at. And you need to figure out how many plants are in those 3 measurements and write that down on your paper. Push play when you're ready to check. Okay, so you should have gotten 16 plants because there are 5 right here, and then when you go over here, there's 1, 2, 3, 4, 5, 6, 7, and 7 and 5 together make 12. And then when you go over here at 63, you've got 4 more X's, and whenever you put 12 and 4 together, that gives you 16. Okay, so we've got a few more questions that we're going to look at. This top one says, write a number sentence to show how many plants do not measure 62, 62.5, or 63 inches. So it's like you're just going to put a slash through these numbers right here because you're not even looking at those. You're looking at all of the other measurements and you're going to write a number sentence or like an addition sentence or whatever type of sentence that you're going to choose to write to figure out how many x's there are for every other measurement that is not those three measurements. So I want you to get a number sentence written on your paper telling me how you solved it, how many x's there were, how did you figure out how many x's there were, and push play when you're ready to check it. This is one way you could have solved it. We knew that between 62, 62 and a half, and 63, there were 16. We know that there are 30 x's altogether, so instead of going to all of these other ones and counting all of the x's, you could have taken 16 away from 30 and it would have left you with 14, which is how many more x's there were on all of the other measurements. If you didn't do it like that and you maybe wrote 1 plus 2 plus 3 plus 3 plus 3 plus 2, I'm totally fine with that too, as long as you wrote down a number sentence on your paper showing me that's how you figured out how many other plants there were that didn't measure those three measurements that we crossed out. This right here in green says most of the sunflower plants measure between 62 and 63 inches. So now we're looking at these. Okay, so we have to see if that statement is true. We know already that between 62 and 63 there's 16 plants. We just figured out right up here that there's 14 plants that measure all of the other heights. So this is asking, or this is saying that most of the sunflower plants fall between 62 and 63 inches. And that statement is true because we've figured that out. There's 16 plants right here, and all the other ones, there's 14, and that tells us that 16 is more than 14, so there are more plants that fall between 62 and 63 inches. Okay, now we're going to be ready for the problem set, so if you want to get that out and have it ready. Okay, so working again with creating your own line plot. And this one is not going to have the measurements on the line already for you, and you see that there's not even a line there for you to use. So you're making your own line, you're making your tick marks, you're putting the numbers that need to go there, you're labeling it, putting a title on it. You're doing everything that we've learned so far to do with line plots. So let's read what this line plot is about before we begin. So it says, Delilah stops under a silver maple tree and collects leaves. At home, she measures the widths of the leaves to the nearest fourth inch and records the measurements as shown below. So that tells us already that we're definitely going to need to be working with fourths whenever we're making our line plot. And you can see on here that we have some fourths, like 3/4 and 1/4. You don't see any 2/4, but that should be a hint to you because we know from the past few lessons that 1/2 is the same thing as 2/4. So really, whenever you say 6 1/2, you should be also thinking that it is 6 2/4 because whenever we make our line plot, you can label it as 6 1/2 or 6 2/4, but you're just going to have to remember that 6 1/2 comes in between 6 1/4 and 6 3/4. That's why sometimes it's easier to use it as 2/4 instead of 1/2 whenever you're working with other fourths. So just remember that whenever you're making your line plot. We're going to have to get a line drawn, and what I would suggest for you is that you just go ahead and put your title for your line plot. And remember, you're going to look at the chart to get the title for the line plot, which is the widths of silver maple tree leaves. We know that the numbers that we're dealing with are in inches, so that's definitely going to be a label. And we know that each X is going to represent one tree leaf, because it's not a tree that we're measuring, it's the leaves that we're measuring. So the 1X is going to represent one leaf. So you got to make sure that you put that down correctly. And then remember that whenever we are putting our numbers, you got to look for the smallest measurement and the largest measurement, so you know what's going to be the first and last tick mark. And then you've got to label the numbers in between and make sure you're putting the fractions correctly on the line plot. So I'm going to let you go ahead and get started on this. And then we're going to have some questions to answer about this line plot once you've made it. So whenever you are ready and you have your line plot finished, I want you to push play so we can check it. Okay, so this is what your line plot should have looked like. If you had 5 1/2 or 5 2/4, that's also the same because we know that 1/2 and 2/4 are the same fraction. So we had 1x for 5 1/2, 3 x's for 5 3/4. We had 1, 2, 3, 4, 5, 6, 7, 8 x's for 6 inches. You had 3 x's for 6 1/4 inches, 4 x's for 6 1/2 inches, and 1 x for 6 3/4 inches. So now we're going to be doing some flipping back and forth because you're going to have some questions to answer about this particular line plot. It says explain the steps you took to create the line plot. I'm not even really worried about that. As long as you are able to make the line plot, you don't have to answer question B. So I'm just going to mark question B out, and we're going to move on to question C. How many more leaves were 6 inches wide than 6 1/2 inches wide? So we're going to have to look back at the line plot, and that's 6 inches and 6 1/2 inches. So here's 6 inches, and here's 6 1/2 inches. 6 inches had 8 leaves, and 6 1/2 inches had 4 leaves. So we're finding the difference between 8 and 4, and that's pretty easy because we know that that would be 4. So there were 4 more leaves that were 6 inches than 6 1/2 inches. And then question D says, find the 3 most frequent measurements on the line plot. What does this tell you about the typical width of a silver maple tree leaf? So it says find the 3 most frequent ones. So the 3 most frequent ones would definitely be 6 inches, 5 3/4 inches, and 6 1/4 inches because those have the most X's. So that's the first thing that we're going to have to answer is just putting down the measurements of the 3 most common ones. So 5 3/4, 6 inches, and 6 1/4 inches. Hopefully I can remember that when I'm typing it. So 5 3/4, 6 and 6 1/4 inches are the most frequent measurements. Then it says why or what does this tell you about the typical width of a silver maple tree leaf? So that tells me that the typical leaf is usually between, I spelled that wrong, between 5 3/4 inches and 6 1/4 inches. As long as your answer is very similar to that question, for my answer, then you're good to go for question D. Okay, so you're ready to move on to the exit ticket. Whenever you have that completed, I would like for you to bring that to me so we can check it.